Apollo 13, a triumph of human ingenuity. By April 1970, the Apollo program had already achieved what many thought impossible. The world had watched, awestruck, as Apollo 11 placed the first humans on the Moon less than a year earlier. Apollo 12 had refined lunar exploration, proving precision landings were possible. By Apollo 13, however, public fascination had waned. Few television networks broadcasted the mission, and even NASA insiders acknowledged that landing on the Moon was beginning to feel routine. For the crew, though, Apollo 13 was far from ordinary. The mission aimed to explore the Fra Mauro Highlands, a geologically rich region that scientists believed held clues to the Moon's ancient history. The astronauts selected for this journey represented a balance of experience and skill. Jim Lovell, the mission commander, was a seasoned astronaut and the first person to fly to the Moon twice. Fred Haise, a former Marine aviator and test pilot, would serve as the Lunar Module pilot. Jack Swigert, a late replacement for Ken Mattingly, rounded out the team as command module pilot. Swigert's inclusion, just days before launch, added a layer of tension. Though highly capable, he had less time to train with Lovell and Haise. Chapter 1. Countdown and Liftoff. On April 11, 1970, at 13:13 Houston time, the Saturn V rocket carrying Apollo 13 thundered off the pad at Kennedy Space Center. Lovell, Haise, and Swigert were pressed into their seats by the immense force of the launch as the 363-foot rocket carried them into Earth orbit. For a brief moment, everything felt flawless. "She's riding like a dream," Lovell radioed back to Mission Control, the veteran's calm tone masking the incredible power propelling them upward. Once in orbit, the astronauts prepared for the translunar injection maneuver, a precisely timed engine burn that would send the spacecraft hurtling toward the Moon. The maneuver was executed flawlessly, and the crew began their 3-day journey to their lunar destination. Chapter 2. Life on Apollo 13. The spacecraft consisted of 3 key components: the command module Odyssey, Haise, which housed the astronauts during the journey; the lunar module Aquarius, designed to land on the Moon; and the service module, which carried essential supplies and the propulsion system. Inside Odyssey, the crew floated in weightlessness, surrounded by a jungle of switches, circuit breakers, and displays. Meals were prepackaged and dehydrated, requiring careful handling to avoid floating crumbs. Communication with Mission Control provided a lifeline of guidance and information, though moments of levity were common. During the second day of the mission, the astronauts even broadcast a playful TV segment, showcasing the challenges of living in zero gravity. The mood was light-hearted, as Swigert demonstrated how to drink floating water globules, and Haise explained their planned lunar activities. Unknown to them, few people were watching. Chapter 3. The Explosion. At 55 hours and 54 minutes into the mission, on the evening of April 13th, the mood aboard Odyssey shifted dramatically. As part of routine operations, Mission Control asked Swigert to activate fans in the cryogenic oxygen tanks. The procedure, designed to stir the liquid oxygen and prevent stratification, was standard. Swigert flipped the switch. Seconds later, a deafening bang reverberated through the spacecraft. The cabin shook violently, and warning lights illuminated the control panels. Swigert's instincts kicked in. "Houston, we've had a problem," he reported, his voice steady but strained. The crew scrambled to understand what had happened. Lovell peered out the window and saw a plume of gas venting into space, a harrowing sight. Inside, instruments confirmed their fears. One of the service module's oxygen tanks had exploded, and the second was rapidly losing pressure. Without oxygen, the fuel cells powering Odyssey were failing. Chapter 4. Contingency Plans. Mission Control quickly realized that Apollo 13's primary mission was over. The focus now was survival. Lovell and his crew, relying on their extensive training, began implementing emergency procedures. The immediate decision was to power down Odyssey to conserve its limited resources for re-entry. The lunar module, Aquarius, designed to sustain 2 astronauts for 2 days, became their lifeboat for the journey home. Powering up Aquarius was an arduous process. Systems meant for lunar descent had to be repurposed for deep space navigation and life support. Haise and Lovell worked methodically, flipping switches and activating circuits under the direction of Mission Control. Swigert, meanwhile, coordinated the shutdown of Odyssey. The transition to Aquarius marked the beginning of a grueling ordeal. Chapter 5. The Fragile Lunar Module. Aquarius was never designed to support 3 men for the extended journey back to Earth. Its resources, oxygen, water, and battery power, were stretched to the limit. Temperatures inside the module dropped as non-essential systems were turned off, and condensation coated every surface. The crew donned extra layers of clothing and huddled together for warmth, their breath visible in the frigid air. Water rationing was strict. Each astronaut was limited to just 6 ounces per day, barely enough to stave off dehydration. Meals, already unappetizing, became nearly inedible as the cold hardened the dehydrated food packs. Haise, suffering from a urinary tract infection, endured severe discomfort but continued to perform his duties without complaint. Chapter 6. Engineering Ingenuity. Back on Earth, Mission Control became a crucible of ingenuity and teamwork. One of the most pressing problems was the buildup of carbon dioxide. The lunar module's CO2 scrubbers, designed for 2 men, were overwhelmed. Engineers quickly devised a solution. Using duct tape, plastic bags, and other spare materials, they crafted an adapter to fit square filters from the command module into Aquarius's round scrubber openings. The astronauts followed detailed instructions to assemble the contraption, nicknamed the mailbox. When the CO2 levels stabilized, it was a moment of triumph that lifted spirits both on Earth and in space. Navigation was another critical challenge. With Odyssey's guidance computer offline, the astronauts had to rely on manual calculations. Lovell used a sextant to align the spacecraft with visual landmarks, including Earth and the Moon. These readings, combined with data from Mission Control, guided crucial course corrections. Chapter 7. Course Corrections. 2 major engine burns were required to ensure Apollo 13 would return safely to Earth. The first, executed using Aquarius's descent engine, placed the spacecraft on a free return trajectory. As the spacecraft swung around the far side of the Moon, the crew caught a fleeting glimpse of its surface. For Lovell, it was bittersweet. He had walked in the Moon's shadow but would never set foot on its surface. The second burn, lasting just 14 seconds, corrected their re-entry angle. Too shallow, and they would skip off the atmosphere. Too steep, and they would burn up. The astronauts worked with meticulous precision to execute the maneuver, using Earth's position in the window as a guide. Chapter 8. Preparing for Re-Entry. As Apollo 13 approached Earth, the focus shifted to reactivating Odyssey. After days of dormancy, its systems had to be brought online without overloading the fragile power supply. Swigert, following instructions relayed from Mission Control, methodically powered up the spacecraft. The process was nerve-wracking. Any misstep could jeopardize the mission. As the lights flickered on in the Odyssey, the crew felt a flicker of hope. They were ready for the final, perilous descent. On April 17th, the spacecraft entered Earth's atmosphere. The re-entry corridor was just 2 degrees wide. Too much deviation, and disaster awaited. As Odyssey plummeted through the atmosphere, radio contact was lost, a normal but excruciating part of re-entry. For 4 minutes, Mission Control waited in silence. Then, a crackling voice broke through. "Houston, this is Odyssey." Cheers erupted. The spacecraft had splashed down safely in the Pacific Ocean, where it was recovered by the USS Iwo Jima. The legacy of Apollo 13. Apollo 13 never reached the moon, but it achieved something arguably greater. The mission demonstrated the resilience, ingenuity, and courage of the astronauts and the NASA teams who supported them. Lovell, Haise, and Swigert returned to Earth as heroes. Their story a testament to the human spirit's ability to triumph over adversity. Their journey is remembered not as a failure, but as one of NASA's finest hours. A reminder that even in the face of catastrophe, teamwork and determination can turn the impossible into reality.